Now we discuss a problem in four derivatives. Four derivatives. The problem is, let f of x equal to mod x, modulus function. Then find all four derivatives. All four derivatives. Four derivatives means d plus f of x, d minus f of x, d plus f of x, d minus f of x. What is d plus? First d plus raised to plus, d plus. This is called upper right derivative. Upper right derivative. Then d suffix plus, that denote what is d suffix plus, that is called lower right derivative. Plus means right, minus means left. Then plus is raised to, then upper, then plus is suffix, then lower. Similarly, d minus, that is raised to minus, that is called upper left derivative, and d suffix minus lower left derivative. The four derivatives there. Our question is f of x equal to mod x. Okay. Then first find d plus, d raised to plus, means upper right derivative at 0. Then formula for that is limit h tends to 0, right means 0 plus, tends to 0 plus, supremum, by definition, supremum f of h minus f of 0 by h. The general formula for that is upper right derivative of f of x means that is equal to limit h tends to 0, right, that is plus f of x plus h minus f of x common by h. That is definition for upper right derivative. Here at 0, then h, then x equal to 0. That is x 0, 0 plus h 0, h, that is f of h minus x is 0, 0, 0. That is the definition of upper right derivative at x equal to 0. So that is equal to limit h tends to 0 plus, then supremum, that is using supremum, then f of h, that is mod h, then f of 0, f of x equal to mod x, then f of 0 equal to 0, therefore mod h by h. Here h from right side of 0, right of 0, so h is positive. When h is positive, then mod h equal to plus h, that is mod h equal to plus h, then h are cancelled, that is equal to 1. Supremum of 1 is 1, therefore limit h tends to 0 plus 1 equal to 1, that is upper right derivative is 1. Okay. Then the second part is d plus f of 0. D plus f of 0. Lower right derivative. That is formula for that is limit h tends to right, so 0 plus, from approaches from right of 0, that is h tends to 0 plus, then lower we use infimum in the place of supremum. Here use infimum, then f of h minus f of 0 by h. Then if 0 equal to 0, that is the limit h tends to 0 plus infimum. Here h is the right of 0, then h is positive, then f of h is mod h equal to h, then h by h, your answer is 1. Okay, that is right derivative upper and lower are equal. Then the third derivative d minus fx, lower left derivative. Lower left derivative. Lower left means limit h tends to 0 minus f of x plus h, that is here 0, then f of h minus f of 0 common by h, then f of h is, then lower here using infimum, lower infimum, upper supremum. That is definition for that. H tends to 0 minus, then what is f of h, that is mod h by h, and h is lies to the right side of 0, that is h is negative. When h negative, mod h is negative, that is minus h by h, that is minus 1, that is lower left derivative is minus 1. Okay, similarly lower right derivative d plus f of 0, we can prove that it is also 1. Therefore upper right derivative 1, lower right 1, and upper left minus 1, lower left minus 1. If they are equal, all are equal, then we say mod x is differentiable at x equal to 0. Here they are not equal, therefore mod x is not differentiable at x equal to 0. Okay.